Hello everyone, welcome to my latest project. It starts out with some Damascus here. I think this has 12 layers in it, maybe a little more. This is going to get twisted. And here's kind of the approximate kind of design I'm looking for. It's going to be a large folding knife. So here as I have this billet in the furnace, and here I am, I'm going to twist this up. I'm going to do a pretty good amount of twists on this. And see, I'm just doing my initial twists, and I'm going to twist this till it almost looks like threaded rod. So here you can see I keep going. The ends of these always get a little mangled. You can't really utilize the ends. So here I just keep going. I'm going to really good. I actually twist this until it almost might shear. But I'm subsequently going to forge this again. So I'm not too concerned if this is a little, if there's some shearing involved in this, because you can twist this to where it'll shear off. It'll actually separate. That would be bad. So here I am. I went through 3 or 4 heat cycles of twisting. And here's what it looks like after twists. So now I'm going to straighten this out. I'm at forge welding temp. You can see that little halo coming off here. I'm going to flatten this down, kind of draw it out. It's not going to be square. I need this to be rectangular. So I'm going to draw this down a little and stretch it out. I need a certain size, and I'm going to discard the ends. Those ends always end up as waste. So here I am at forge welding temp. Look at that halo. So I'm going to draw this out. And I have a little spacer in my, you can't see, it's behind the metal. It's in my flat dies. And that keeps it a very consistent height. The dies go up against that piece and kind of, there you can see them there. But this gives me a very consistent thickness. So I'm looking for a certain thick. I think I was looking for 3/4 of an inch thick. So here's the two pieces. Now I cut them in half. I bisect that. Okay. Once it's bisected, I'm going to flip them around upon each other, and I'm going to put a center strip of 2 pieces of 15 and 20. It's 2 pieces of nickel down the center. And so this is going to get drawn out into my knife billet. So I have the twists on either side with the center section. So this is called autogenous welding. It's a fancy word. You're just fusion welding, so you don't add any rod. There's no rod being added. That would contaminate this billet. So you just run the torch over this, and it fuses the 2 surfaces together without adding any rod or material. And here it is after fusion welding all the way around, so no oxygen can get into this. It's critical there's no oxygen in there. So here I am, my first heat on this fusion, and I'm being a little cautious on this. I can't let this get too thin, so I only have a few heats to get this press done and get it fused. So here you can see I'm at forge welding temp. So now I'm at perfect temp right here. This press right here, I can feel it's totally solid. So I'm good to go. Now I can, once it's fused together, I can start flattening it and drawing it out. So I reduce the height a little bit here. I do a couple little light presses here, and then I turn it over and I start drawing it out. And the ends will be waste once again on these. It's just, you plan around it. If you do a project where your billet is forged really close, you might have a problem because you might run out of material. But here's, I drew this out to a certain thickness. I think I was going for 1/4 inch thick or 5/16. But here I'm gonna shape the tip, a general shape, and get this drawn down on the end. I'm looking for a kind of a taper. It's a certain radius I'm looking for, and then the back of this blade will taper back in. Here you can see I'm getting this approximate kind of curve as it kind of curves back on itself, almost like a spear point. So here's after forging, rough forging. I'm a little thicker than I wanted, which actually is fine. I'll grind back. And here's my blade shape. This is my blade shape. So I got a lot of grinding ahead of me. And I edited a lot of this out. You probably want to see, an hour and a half of grinding. So I'm going to give you guys the highlights. So I kind of use this, my platen here as kind of a surface grinder. I got these flat and ground parallel, and I'm just kind of reducing the thickness now. And now I'm kind of reducing it further. Got the general shape pre-beveled there. It's coming along nicely. Now, my next shot is going to be with the contact wheel. I have a 10-inch contact wheel. And then I have a beveling jig you can see here. I made this beveling jig myself. And I have my belt sander running in reverse so it pulls away from me. There's no danger. If it was turning towards you, it'd kind of be dangerous. Could kick that knife towards you, but so this is my beveling jig. I'm getting my bevels very precisely cut in. And so moving on to the handles. This is grade 5 titanium at 0.161 inches thick. Now these will be the handles. So I'm going to basically cut out these strips. They're just under 1 inch in width. And they'll finish down to a little smaller than that. But here's the main handles. And they're around 9.5 inches long. Something like that. So I have them clamped up with the blade. I'm going to center mark for pivot points. You can see my center mark there. And I'll drill through the handle and through the knife. And there were some measurements I had to take to get this geometry right. And I don't show it in the video, but. And so after I drilled those holes, those got chamfered. These titanium handles got chamfered, and then the other side will be threaded. So, and then here's the ends there's actually 4 locations that will get recessed screws. So I have to through drill, and here I am chamfering all the holes. I don't show all these holes. There's quite a few holes to chamfer, and this gets chamfered. And then I do a test fit here. And make sure that fits flush. And here I am threading the handles. This is quarter 28 threads per inch. So going very careful. This is the titanium. It threads okay. It's a little different than steel. It's a little gummier in my opinion. So you have to be a little careful. You have to go in, back out. Take your time, but both these handles tap nicely. Now these are the spacers. I had to make 4 of these, and this is just getting parted off. But these little spacers will get parkerized black, and they sit in between the handles. And these are threaded 832 threads per inch all the way through. So I made 4 of these. Now the handles are kind of done. I mocked it up to drill my stop pins. And so here's one stop pin that's done. That's going to have a pin that gets pressed into it. And there's another one on the other side. Here I unfolded it and clamped this and aligned it. And now I'm cutting the second pin. That'll get the pin slot. It'll get pressed in. Now the handles get relieved. I want to use when it's folded. I want to see the blade through the handles. So this Damascus is going to look very, it's very visual. I want to be able to see that. And also, when it folds back on itself, I want it to be thinner. That would be too wide to grip. So I milled these slots on both sides. So when it folds out and the knife's extended, the grip is a little more comfortable and it's narrower. Now here's my own design of a magnetic link. This link locks in the open and closed position at pivots. And it's just got a rare earth magnet pressed into it, but I machined and this little link here. Now here's my heat treat. I thermal cycled this. Twist Damascus can sometimes warp during heat treatment. So I don't show it on the video, but I thermal cycled this blade quite a bit to stress relieve it before heat treat. Now here I am polishing. I take this blade all the way up to 1000 grit. So I think I'm at 120 here or 220, and then I go 320, 400, 600, 800, then 1000. And I polish the bevels and the knife. So here's my pins. I machine these pins out of the tool steel, and I made 2 of them, and they're just a press fit. They both get pressed in. So here's the knife after sharpening, polishing, up to 1,000 grit, and the pins are pressed in. This is it. So the next, this is the finished blade before etch, and it came out really nice. So here's the blade after a quick dunk. I think I did three cycles of etching with cleaning in between each cycle. So I etch for so many minutes, take it out, uh, clean it off, neutralize it, rinse it, put it back in, and I did that 3 times, 3 etch cycles to get this contrast level on darkness. Uh, I could have made the nickel a little brighter if I wanted to hit it with 1,000 grit in between etching cycles, but this is the color range, the darkness contrast I wanted with this. So it came out really good. Now here's the completed handles. This is titanium with steel spacers, and you can see everything's been done, and the corners have been kind of beveled, and 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 all the sharp edges have been removed. So these are the finished handles. The handles are done. They're very light. Came out really nice. Very strong handles too. And here's the locking mechanism. It pivots and locks in the open and the closed position. And then there's just a steel tab inside the other handle that it locks up against. So here's my bronze washers I made, and you can kind of see it's chamfered and has a through hole, and the outside diameter of this is 0.875. And so I parted these off, and here's one of them. I had to make 4 of them, and they were about 6.060 thick. Now here's all my little steel spacers and my link. They're going to get parkerized. And my parkerizing solution, I mixed it up myself, but it gets a very dark color, a very dark black. So here's all my steel fixtures getting parkerized black. So they turned out really nice. Now I took I sanded these handles to 3,000 grit because it's going to get an entropic, or what sometimes people call entropic finish. So the titanium is heated to about 550 degrees. You can see my wife there. She's got a little infrared thermometer, and she's taking some shots. I want this around 550, and it gets dunked. You can see here it's got a little bronze color to it. At around 550, you dunk it in ferric chloride. Now it's not diluted. It's straight ferric chloride. So it's very high concentration. And there's a chemical reaction that happens with the titanium at temperature, and this is what I call lightning. Look at this, guys. This is a lightning finish. Looks like electrical current or some type of lightning is traveling down the length of the handle. It's known as an entropic finish. Some people call it lightning anodization, but it's not anodizing because there's no electricity involved. It's just a chemical reaction. And here's all my handles. And you see how variegated they are? Each one comes out a little different. And entropic means entropy, right? There's some variable. It's quite variable, but I love the randomness, to be honest with you. These handles came out just phenomenal. Love this finish. With the Damascus, the contrast is just amazing. So here I have some assembly coming up, and and the assembled knife here. Now you can see this. There's a bit of a taper built into those washers. It allows the handle to kind of unlock with a little side pressure, and then it flips up and it relocks again. So it locks open and close, both. But look at this, guys. Here's the handles. This came out beautiful. I love the contrast of the color and the grayscale of the Damascus. And this has a decent edge on it. To be honest with you, I was a little concerned. I was flipping this thing around. My knife handling skills with a butterfly knife is not, the best. I was actually concerned I'd cut myself, but look at that pattern on that blade, guys. Here it is. You'll see this unlocks very easily. Click. And it's still a little tight. All this stuff. It kind of has to break in a little bit, and it just locks in place. A little flick, and that locks in place. And you can unlock it with a little bit of side pressure. Click, and then it just unfolds easily, and then locks back again. A little magnetic link there. So that magnetic link works really well, and that's been done. Other knives have magnetic locks. It's not nothing too ingenious, but and I have to say this. I say this probably every video. This is my favorite. It's my favorite. Um, this was just phenomenal. I love this the titanium handles, and the weight on this is not bad, guys. Some of the knives I've done, they're a little big, and some of them can be considered. I don't think they're heavy. Other people have handled them and like, hey, this is kind of heavy. This one, everyone has said, hey, this is really light. So I think it's a good balance. Now look at it. You can see that pattern through the handles. Look at that. I love this pattern. Um, I just love this Damascus pattern. I'm in love with the handles. And I could have, got it a little. It could have been a little lighter, the contrast level and the overall darkness, but I wanted it darker. It seemed to contrast better against the titanium. How bright and vibrant the titanium is. I almost wanted the blade darker, right, to increase that pop, to make it even more of a a disparity. So where the blade's even thick, darker. Normally, I probably wouldn't make a blade that dark. Or I'd polish the nickel a little bit with some Scotch Brite to bring out the shine of the nickel a little bit better. But I love this. I think this is perfect. This is one of my favorite one, guys. Let me know what you think. And I really want to know your opinion on this, but it's not too chunky. I almost like it. And to be honest with you, this is when I started this project, I asked myself, what if a Jedi, what if a Jedi had a butterfly knife? What would it look like? And this is what I came up with. This is my vision of if a Jedi had a butterfly knife. You know, um, that's kind of my conceptual how I conceptualize this. And so it's a pretty good sized knife. Um, and it's very sturdy. There's no play in those handles. I got all the machining done correctly. And look at this, guys. It's one of my favorite. Came out beautiful. And I hope you guys like it. And tell me what you think. I want you, everyone, to stay safe out there. I'll see you on the next one. Thank you.